Hi, everyone. Hope everyone's having a good day. Thank you all for coming to my webinar today. I'm going to present how to turn bare metal into AI powerhouses using Mirantis' Cordon AI. My name is Angelica Ambrosio, and I am a product marketing specialist here at Mirantis. My focus is on Cordon AI, and I'm passionate about developer advocacy and building meaningful connections with the developer community. So my background is about technical marketing, platform engineering, DevRel. I was also a teacher at one point, so education and technology are both my passions. And I love creating content that makes these complex text concepts easier to understand for everyone of varying skill levels. And for those who are not familiar with Mirantis, we are the original private cloud pioneer. We built our reputation helping enterprises run OpenStack at scale, especially those with the complex high performance infrastructure needs. After building and operating some of the world's largest clouds, we are now focused on tackling the next big challenge: AI infrastructure for enterprises, service providers, and neoclouds. But let's take a quick look at our global footprint. We work with thousands of customers across 85 to 90 countries. We've got teams in more than 15 ready to service them. Our customers span almost every industry, especially software, finance, and telecom. What really sets us apart is our customer first approach. Beyond our technology, we provide managed services, professional services, and an in house security team, giving customers the confidence to move fast without worrying about resources or execution. We handle the complexity so our customers can stay focused on what they do best, driving innovation and results. Let's go into our agenda. So today we have a few demos, just two. So we're going to talk about service stackup. We're going to talk about GPU enabled services deployments. And then I'm going to show you how Cordant AI solves a lot of these bottlenecks and problems that come with GPU enabled service deployments. So let's talk about service stackup, the need for speed. In today's market, we have lots of AI products popping up everywhere, right? So, with this, a lot of companies and enterprises need to be able to have a product ready in order to be in the competition for a lot of these AI products. And there is one bottleneck that we've seen a lot of enterprises have, and that's with deploying GPU workloads. GPU workload deployment basically means you're running the apps that need extra power from a GPU. These are usually tasks like training AI models, doing heavy scientific calculations, or running fast real time predictions. You can run these workloads either in the cloud or on prem. To make everything work smoothly, you can set up servers that have GPUs and then use tools like Kubernetes to decide how much GPU power each job gets, when it runs, and how it scales. In short, it's all about giving demanding apps the GPU power they need and managing it in a smart, automated way. And when teams deploy these GPU workloads, they often run into what we call operational overhead. AI environments end up inconsistent because everyone configures things differently. That also leads to painful manual setup and integration work. Every project, every model, every time. New team members take longer to onboard because they have to learn complex GPU setup steps instead of just jumping in and get started. Upgrades become risky and difficult to manage, especially with GPU drivers, libraries, and frameworks all have to stay aligned. And over time, clusters and services drift out of sync, causing unexpected errors, which can slow everything down. All of this ends up to a lot more effort just to keep your GPU workloads running smoothly. If only there was a solution to streamline the process of deploying GPU workloads. But there is. I'm going to talk about Mirantis Cordon AI and how this solves the issue of deploying GPU-enabled services. Cordon AI is designed to help address the crucial challenges associated with AI infrastructure. So Cordon works across public, private, and GPU clouds. It's built for flexibility. It has a composable architecture, meaning you can mix and match the stack components you need, and you can even evolve them over time. Unlike competitors with rigid one-size-fit-all stack, Cordant gives you complete choice and control. It offers true tenant isolation, so multiple users can safely share the same infrastructure. There's an integrated catalog for value-added services, letting you easily build and offer new AI capabilities. Configuration reconciliation ensures everything runs just as you expected, automatically detecting and fixing any issues. The Cloud Console gives users a familiar cloud-like experience with self-service tools and visibility. Ultimately, Cordant helps clients maximize GPU utilization, package and bundle the services to meet the customer needs, and monetize their infrastructure through differentiated offerings. And we're going to talk about a little bit about Cordant AI and how it simplifies infrastructure. So, if you watched my previous webinar, I talked a little bit about how Cordant AI can provision bare metal servers. Well, we're going to talk about the AI PaaS, AI Platform as a Service. So through this, we're going to talk about how we can configure GPUs, build clusters as needed, add key services like the NVIDIA GPU operator by default, and let you layer on your AI tools for training or inference. So the TLDR, Cordant AI gets your AI infrastructure ready fast with everything set up already for you. So you can worry about innovation and let us handle all the complexities. So, we're going to talk about how exactly that we make deployments of services simpler. So, we have a curated AI catalog for easy access to all of your AI essentials. One-click deployment of GPU runtimes and supporting services, and everything is like a blueprint-based setup. We have ready-made customizable templates so you can streamline all the services that you need just for your AI application. We have automated management for upgrades, versionings, and backups. So that way, when you update, you don't have to worry about any downtime or any like configuration drift. And let's talk more about the integrated catalog. So I have on screen a picture of our services catalog for Cordant AI. So it's a turnkey pre-validated library of integrations. And it's extremely customizable so you can meet your customer requirements. So you can go into the templates and make additional configurations per your customer's requirements, that sort of thing. This gives you complete flexibility and control. It also enables NCPs to quickly stand up for your commercial offerings and has a tight integration with observability and billing. And it also, if you think about it, if you're just deploying services, bam, 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 with the templates, this makes it a lot faster to get what you want, your product, out to your customers. So, from a user experience perspective, integrated catalog, we have the defined infrastructure and services. Customers can also easily configure this catalog. There's the operator console for configuring the environment and commercial offerings. And we have the cloud console for customers to then consume those services so that you can brand it with logo or color. So the end-to-end idea is to bring all the parts that you need to quickly devalue value to your customers. So now that I've talked a lot about Cordant AI and how it fixes the problem of deploying GPU workloads, let's go ahead and see this in action. So first, I'm going to show how easy it is to provision an AI inference cluster. But before we dive into that, for those who don't know, AI inference clusters are a group of connected servers, usually with GPUs, that work together to run AI models and make your predictions quickly and at scale. So let me switch over to our demo. So as you can see, we are going to provision an AI inference cluster. So first, we're going to create the cluster by going into the UI. So this is the Cordant AI UI. We're going to create a cluster by going up in the top right, create cluster. I'm going to give the cluster a name. And then let's go ahead, give it a namespace. And then here is the templates that I talked about earlier. So we have all these templates available. We have AWS, Azure, Bare Metal, GCP, Docker. This shouldn't look completely foreign to you if you watched my last webinar, but this is how easy it is to create clusters using Cordant. So all you have to do is select a template from the list. So here, I'm going to use the AI Inference Cluster template available through AWS. So this AI Inference Cluster is optimized for AI ML inference workloads, and it has GPU support, and it already has pre-configured GPUs in it. So we're going to go ahead and select that. And as you can see, all I have to do is add the provider credentials and configure my control plane nodes and select the AWS region. Once that's done, I can look and see, oh, we have some additional configurations with the YAML editor. So as I mentioned, you can customize it for your customer's needs. Here, it's easy to tailor like exactly what the customer is looking for using the YAML editor, or we can use the control plane instance, AWS region. All this is available. So that way you can still get the velocity you need with deploying these services without sacrificing any customization. So now that that's out of the way, we're going to connect our GPU to our AI inference cluster so we could run models more quickly. So here's the GPU configuration. As you can see with the template, it already had like a pre-configured template for which GPU we're going to use. How do we get that? Well, if you look down in this blue box, GPU instance information, GPU instances are optimized for AI ML inference workloads. So we have a key here. We have like the G5 instances, P3 instances, G4DN instances. So this will help you figure out which GPU instance that would work best with what you're doing. So here we have like the G5 is better for inference and training, right? And that's exactly what we're using, the G5. The P3 would be excellent for training the workloads, and G4DN is more cost effective. So you see how instead of you trying to experiment with what GPU you need to use, we help you do the thinking. And that way, all you have to worry about is trying to get your application running without worrying about what resources that you need to use or whatever, right? So once I get that configured, I have some services that are already here. So I have the NVIDIA GPU operator, the Run AI backend, and I have Argo CD for deployment. So we're going to go ahead and create this cluster. And as you can see, my AI inference cluster is ready with services already deployed in it. So I can use this AI inference cluster to start training or doing work inference with my AI models. So I have one GPU and I have all my services ready. And that's essentially how we create an AI inference cluster just using Coordinate. I only took like a couple of steps because most of it was already configured for me using the template. All right, now we're going to talk about Run AI. If you were an eagle eye, you could see that I was hinting towards it in the demo that Run AI was already installed in it. And then using Run AI, we can actually just start talking to our models. So I'm going to talk a little bit about the demo before I show it to you. So in this demo, I have the cluster ready and I have Run AI already in it. And then using Run AI's backend, I can actually start talking to the LLM. And how do I do this? Well, I'm going to show you in the demo. So I'm going to go ahead and use Run AI with Cordant. So as I mentioned, here's my cluster. So I have my cluster here. It is the AWS template, and it has FIPS already in it. And we have Run AI already installed. So if I scroll all the way down, you can see here, it's my Run AI FIPS, my status conditions. Okay, everything's good. And then we go down to services. We have the NVIDIA GPU operator, Nginx, Cert Manager, Prometheus, Run AI backend, which is our most important right now for this demo. So I can actually go into the Run AI backend and see, oh, look, it's my cluster, right? So I have my cluster here. It's connected. So we're going to build an inference. So how do we do that? So we're going to go here and we're going to give the inference a name. So I'll call it NIM LLM. And then I'm going to pull an image. So I'm going to pull an image actually from the Mirantis secure registry. So I'm going to pull that up. And then I'm going to go down. See how it says MSR? That's how we know where it's from, right? MSR, Mirantis secure registry. So after I get my image, I'm going to go ahead and assign one GPU for the sake of this demo. And I'm done. You see how I only got the inference done in about 3 steps? So I gave it a name, gave it an image, and then I assigned a GPU. So let's see, my inference is initializing. Okay, let's go ahead and start looking at our LLM. We have our connections. So what I'm going to do is I'm going to use this address as the API endpoint. So I'm going to go into connections and I'm going to grab the address here so I can actually start talking to the LLM. So I'm going to use this API endpoint into my command here. So I'm in this command, I'm saying, hey, LLM, which I took from Pi 35 Mini, can you write me a short poem on AI? So I'm going to go ahead and put that in. And there you go. I'm actually started talking to the LLM. I told the LLM to create a poem. And if you look back, all I did was build an inference with Run AI. A lot of the information was already configured using Coordinate. And then I was able to take the API endpoint from Run AI. And then now I'm using it in my command line for LLM or to talk to the LLM. And if I do it again, bam, I have a poem written entirely on AI. You see how much faster it was using Coordinate AI in order to start like creating the AI inference cluster and for training or inference with the LLM. So let's go ahead and review the challenge. Deploying and managing GPU workloads for AI leads to high operational overhead in inconsistent environments. You see, when I was looking through the UI, there wasn't like 50 different fields. I didn't have to worry about having to manage everything at once because Cordant does a lot of that for you and reduces the operational overhead. And then two, the solution. So Mirantis Cordant AI provides that turnkey, full stack automation from bare metal all the way up to AI models running on a Kubernetes infrastructure. So as you saw from the demo, a lot of these things were already automated. I was easily able to start building my AI inference cluster. I was easily able to start talking to my LLM using Cordant AI and Run AI. And then simplified deployment. So save time with one-click deployment from a curated AI catalog. So I showed a little bit of the catalog with the blueprint-based setup that I mentioned and automated management. And then last but not least, the key benefits. So enables faster deployment, a cloud-like self-service experience, and maximum ROI by optimizing GPU utilization. Now, I hope you guys found this session helpful and learned something new today. Through this session, I gave a clear picture of how Coordinate AI can simplify and streamline your AI infrastructure and your server lifecycle so you can be AI ready without the burden. If you'd like to see more, please reach out using the mirantis.com/contact, or we also have the QR code up available if you'd like to just scan it there. Again, thank you everyone for coming today. I hope that you learned something new. So thank you, everyone. And if you have any questions down the line, feel free to contact us at mirantis.com. You can book a demo for a full demo of the Mirantis Cordant AI offerings.